All right, guys. Are there any questions on any of the assignments so far? I don't think there are, because I think most of y'all have turned them in. What we are starting today is logarithms, actually working with logarithms. Now, logarithms are the inverse of an exponential function. And we can change from logarithmic form to exponential form. Log base b of y equals x if and only if b to the x is equal to y. And so the first thing we're going to be doing is changing from one form to the other. B of equals y if and only if b to the y is equal to x. No, it does. Yeah, I flipped the x and y. So I'll rewrite it here so it makes. So log base b of y equals x only if b to the x is equal to y. Now the first thing we're going to do is switch from one to the other. So we're going to start with logarithms, and we want to rewrite it in exponential form. And again, we're still using the fact that log base b of y is equal to x if and only if b to the x is equal to y. Now looking at the first one here, right up there, the base, our value of b for this first one here is what? 2. Inside is y, so our y value in this case is 16, and the x is 4, and our b is 2. So log base b of y is equal to x is the same as b to the x is equal to y. So we have our base of 2. What is our x value? And this will equal 16. And that's it. Now this is easy to check to make sure we got it right, because what is 2 to the 4th? 16. So it is the same. Let's look at the next one. B is log base 4 of 1 equals 0. Well, here our base is 4. Our y in this case is 1, and x is 0. And we want to write an exponential form. B to the x equals y. So we would have 4 to the equals log base b of y equals x if and only if b to the x is equal to y. So the next one here, we have log base 12 of 12 equals 1. If I want to write this in exponential form, how would we write this? 12 to the, that's it. Let's look at the next one. Log base 1/4 of 4 equals -1. How would we write this? And that's it. Now for this one here, we'll want to put the 1/4 in parentheses, signifying that the -1 is attached to not just the 4, but also the 1, the whole fraction. Any questions on this here? So let's do 4 more of these, and then we'll move on. So log base 6 of 216 equals 3 would be rewritten as 6 to the 3rd is 216. Log base 7 of 1 equals 0 would be log base 21 of 21 equals 1. 21 to the 1st is, last but not least, log base 1/5 of 5 equals -1. And that's it. Questions on these here? You like these so far? Now we're going the other way around. Okay, so what do we think for this here? Log base 5 of 25. Yes. Because again, we're saying log base b of y equals x if and only if b to the x is equal to y. Let's look at the next one. 10 to the negative 1 equals 0.1. 0.1 equals negative 1. If we want to put parentheses around the numbers inside the log, we can. That way it's a little bit easier to distinguish what we're looking at. Also, when writing the base, it's good to write it a little bit smaller and down so that we know it's the base and not the number inside. Questions on this here? 8 to the 2/3 equals 4 would be log base 8 of equals so the next one would be log base of 1 over 2/16 equals negative 3. Questions on any of these here? Let's go on and do these since they're not that bad. So log base 9 of 81 is equal to 2. The next one would be log base of 0.05 equals negative 1. Log base 16 of equals 3/4. And lastly, log base 15 of 1 over 225 questions on these here? Now we want to evaluate each of these logarithms. Because we can use the property. Oh, I didn't look at this. Good time. I feel like I'm missing the property. I'm trying to remember how we want to do. I want to do this. Yeah, that's what I thought. Okay. Now what we want to do for this here, because there's different ways to do these, and we'll look at them different ways as we go through the chapter. Because we're wanting to see what log base 4 of 64 equals. Let's rewrite this as an exponential. So how would I rewrite this? Equals 4 to what power is 64? Because we can clear this out. 4 times 4, 4 squared is, times 4 is 64. So 4 to the 3rd is 64, which means log base 4 of 64 is 3. So log base 5 of 0.2 equals x. So if I rewrote this as a logarithm, 5 to the equals. Now this one here is a little bit harder to see. Now, if we changed 0.2 into a fraction, 0.2 would be the same as what? So 5 to what power would give us 1/5? Because really, the value of 5 was moved from the numerator to denominator. Now, if I move it back up, the exponent becomes Any questions on these here? Log base 36 of 6 equals, well, we can say y. So let's rewrite it as an exponential. So we're trying to see what power is going to make 36 into 6, yes? You're right with a fraction, but I wouldn't say 1/6. Because what would we do to go from 6 to 36? Multiply it by 2, yes? So if I'm squaring to get to 36, what would we do to go the other direction? Square root. So we would take the square root of 36. How would I rewrite square root of 36 as a fractional exponent? It would be so log base 36 of 6 is a half, because that's dealing with our radicals. Questions on this here? We can look at the next one. Oh, yeah, that wasn't going to be the eraser. So if we rewrote this as an exponential, we would have what? 1x equals what's something we know about our solution, the value of x? It's going to be negative, yes? Because we're moving from the denominator back up to the numerator, yes? So we could say this is the same as 5 to the negative x is 125. So now we need to see how many times do I need to multiply 5 by itself to get to 125? Yes. So x is going to be what? -3. Questions on this here? Now this here is not so much that we're solving anything, it's just we're manipulating the equations to figure out what the value is. And all these here, it works out nicely. So log base 4 of 256, we're really saying what times 4, how many times do I multiply 4 by itself to get 256? Because what we're saying is 4 to the 4th is, which is true. Now the next one might be a little bit harder to see. So if we rewrote it as an exponential, set it equal to x, we would have what? 8 to the x, yes, is equal to our 0.125. Well, I'm just saying 8 to the x is equal to 1/8, because 0.125 is 1/8. So to get it to go from the numerator to the denominator means that x is -1. So log base 8 of 0.125 is -1. Now our next one would be 1/3 to the x equals 27. Now we know the sign of our exponent is going to be negative. The sign of our solution is going to be negative because we're moving it from the denominator to the numerator. Because anytime we're switching with these exponents from numerator to denominator, denominator to the numerator, going from a whole number to a fraction or fraction to a whole number, what this is going to equal has to be negative. So that deals with the 1/3. Now, 3 times itself, how many times is 27? So here it is -3. And our last one is saying what? 64 to the x is equal to 8. It is indeed 1/2. Because anytime we're decreasing 64 to what power is 8, we're going backwards. We're dealing with fractions. Yeah, exactly. Since we're taking the square root of it, it's going to be 1/2. Now, this isn't on the note sheet, but let's just say log base 64 of 4. Well, that means we're taking 64 to the x is equal to 4. Now this one, x is not going to be 1/2. So it would be 3 because 4 times itself 3 times is 64. So it's not 1/2, it's 1/3 because 1/3 is the cubed root. So what we're taking is the cubed root of 64, which is 4. Because 4 times itself 3 times. Essentially what we're saying is 64 to the x is equal to 4 to the third, and working backwards from there. Not so much that, but the other way around. Questions on this here? Natural logs. ln of x equals y is equal to e to the y equals x. Is the same as e to the y equals x. I need one more marker. It is not written, but the base of every natural log is e. It's understood to be e. So we don't write it in. So whenever we look at these here, ln of x, it's understood to be ln base e of x. We just don't say the base since it's understood. So looking at these here, rewriting them as logarithm or as exponentials, so we know that there is a base e. So how would we rewrite this? It would be e to the 6. ln of 6? But this here, unfortunately, is not asking for the value of x. It's just wanting it in exponential form. Yeah. So the next one, ln of 5a equals b. How would we rewrite this in exponential? E to the b is equal to 5a. Be ready for the next one. ln of 42 equals b would be e to the b equals 42. ln of z equals 6. Questions on these here? ln of 4y equals d. 4 to the e to the e equals 3a. 3 to the a, yes. I see what you're saying, yes. No, yeah, it took me a second. I saw it too. Okay, so let's look at these going the other direction. So we have e to the 9 equals x would be? Now, with these here, because it's understood, e is understood to be the base, we don't have to put it. So the next one, e to the 4a equals c, so ln of equals 4a. Yep, because ln of x equals y is the same as e to the y equals x. E to the 2x equals y would be? E to the 57 equals z. I have a feeling we're still comfortable with these here, yes? Okay. Common logs and natural logs. Evaluate log of 8. So we're going to evaluate log of 8 using a calculator and round to 3 decimal places. So we can take a calculator and hit log 8. Enter. 0.903. 0.903. That's it. Because we're just wanting to evaluate this using a calculator and rounding to 3 places. So our next one is ln of 0.3, which is negative 1.204. Since we're rounding to 3 decimal places, we would have to round the 3 up to a 4. Hence the next number is 9. Let's pull the graphing calculator up. Close. And to pull up E, we can do second ln, or 10 to the x is actually second log. Any questions on these so far? So we can say log of 98 is 1.991. And if we do log of 9.8, we get 0.99 what? 1. Questions on these here? That's it. Question on any of these here? There are some interesting ones, like, say, log of 1. Or natural log of 1. Well, if we look at that, natural log of 1 we said is what? 0. What's this as an exponential? E to the what? Anything to the 0 power except for 0 when 0 is a base. This is 1. So really the natural log or log, no matter what the base is, of 1 is always going to be 0. Yeah, log base b of 1 is equal to 0. That's just one of the properties of logarithms. That's it.